Good evening, students. Today we will see a problem in impending motion. So as we discussed in the class, impending motion means the state of motion of a body which is just about to move or slide is called impending motion. So we will see a sample problem. So the given problem is block B rests on block A and it is attached by a horizontal rope CD to the wall as shown in figure. So we'll see the figure now. Yeah. So block B rests on block A and is attached by a horizontal rope CD to the wall as shown in figure. What force F is necessary to cause motion of block A to impend? As we discussed, impend means about to slide. So the condition given is impending motion. So the coefficient of friction between the blocks is 0.25. So between A and B, the coefficient of friction is given as 0.25. And between the floor and block A is 1 by 3. And the mass of blocks A and B are 14 kg and 9 kg respectively. Force, inclined force is given with an angle of 45 degree. So that force we have to calculate what is the magnitude of that. Based on the given data, so the weight of the block A is 14 kg. So we are converting into Newton. So 14 we are multiplying into 9.81. So we will get 137.2 Newton as the weight of block A. And then weight of the block B is 9 kg. So we are multiplying into 9.81. So we will get 88.2 Newton. So after that, you know that the coefficient of friction between a floor and the block A is 0.33. So I am taking it as mu1, and then mu2 is equal to 0.25. That is the coefficient of friction between blocks A and B. So now step 2, as we discussed in the earlier problem, so we are going to draw the free body diagram of blocks. So first I am taking the block B. So in the block B, you can see that we are having the weight of the block, that is 88.2 Newton, and then we are having a normal reaction to the weight of the block. I am taking it as n suffix b, that is normal reaction which is acting in block B. There is a tension in the horizontal rope CD, that is I am taking it as T. So the body 1, that is the body A, will move towards left. So the movement of block B along with block A is prevented by the tension in the rope CD. So the frictional force at the contact of two blocks is acting towards left. So because the tension is towards right, so the frictional force will be towards left. Okay, so this is the frictional force which is acting on block B. So now we got all the forces and reactions related to block B. Now we are moving to block A. So we are having the self weight of the block, that is 137.2 Newton, and then we are having the normal reaction, that is I am taking as n suffix A, and then we know that there is a inclined force acting at an angle of 45 degree. So this particular force will be divided into two components, that is vertical component F sin 45 and then horizontal component F cos 45. And then because the block is moving towards left, so our frictional force in block A will act towards right, that is F suffix A. So apart from these forces, because of block B also, the forces and the reactions will act on block A. So those forces and reactions are, so the normal reaction of block B will act on block A. So that is, I am taking it as n suffix B, that is normal reaction due to block B. And then because the body is moving towards left, so our frictional force will act on towards right. So that frictional force is nothing but the frictional force of block B. We have calculated the free body diagram of blocks. So this one is block B and this one is block A. We have to check in the each free body diagram how many unknown forces are there. In block B we have frictional force B, and then normal reaction at B, and then tension. These are three unknown. In block A, normal reaction A, frictional force A, and then frictional force B, and normal reaction B, and then F also we have to calculate. So based on the free body diagram, so block A is having more than three unknowns, and then in free body diagram of block B we are having three unknowns. So we are having the equations of equilibrium. Three equations we are having, that is summation of horizontal force equal to 0, summation of vertical force equal to 0, and then F is equal to mu into N. That is frictional force is equal to coefficient of friction multiplied with normal reaction, because the given problem is in impending motion. So free body diagram of block B. So here we are substituting the equations of equilibrium. The first one is summation of forces along horizontal is equal to 0. So based on the free body diagram, we can say the forces which are acting towards right, we are assuming it as positive. So based on that, T minus frictional force at B is equal to 0. So we will get T minus mu 2 into NB is equal to 0. So as we know that the frictional force is equal to coefficient of friction multiplied with the normal reaction. So FB is equal to mu 2 multiplied with normal reaction at B. Okay. So once we substitute, we know mu 2 is 0.25. So T minus 0.25 normal reaction in block B is equal to 0. So from that we can write tension in the rope is equal to 0.25 times of normal reaction of block B. Next one, we know the equation of equilibrium, that is summation of vertical force equal to 0. So here again we are having two forces, that is normal reaction at B and then 88.2 Newton. So we are assuming that the force which is showing upward is positive. So here NB minus 88.2 is equal to 0. So from that we can calculate the normal reaction of block B is 88.2 Newton. So once we calculated normal reaction, then we can move to the third equation. F is equal to B is equal to mu 2 multiplied with normal reaction at B. Otherwise, you can use the first equation, that is T is equal to 0.25 NB. So FB is equal to 0.25 multiplied into 88.2. So we'll get the answer FB is equal to 22.05 Newton. We can also calculate T is equal to 0.25 NB. That is normal reaction, and then you will get the value T is equal to 22.05 Newton. So the next one is we are going to solve the unknown components in the block A. So this is the free body diagram. So just I have added the values of normal reaction B and then frictional force 22.05 Newton. So again we are going to substitute the equations of equilibrium condition. The first one is summation of horizontal force equal to 0. So if you are seeing here, we are having frictional force A and frictional force B, and then we are having horizontal component F cos 45, and these are the three components, force components are acting on block A. We are assuming that the forces which are acting towards right is considered as positive. So FA and FB will be positive and F cos 45 will be negative. So 22.05 plus, so FA is equal to mu 1 into NA. So if you substitute that 0.33 NA you will get for FA. So minus for F cos 45 is equal to 0. So from that we can write like this, that is 22.05 plus 0.33 NA is equal to F cos 45 degree. That is I am assuming at equation 1. So the next one is summation of vertical force is equal to 0. So here if you see, we are having normal reaction acting towards up, and then self weight of block A is acting towards down, and then normal reaction of block B also acting towards down, and then F sin 45, that is vertical component of the unknown force, is acting towards up. So normal reaction at A, and then F sin 45 is acting towards up, and 137.2 and 88.2, that is weight of the blocks, or weight of the block and normal reaction of the block B is acting towards down. So again we are assuming the force which is acting upward is positive, and then we are writing the equation NA which is acting up, that is positive, F sin 45 is acting upwards, that is positive, and minus 88.2 and minus 137.2 is equal to 0, because the given problem is in about to slide or just to slide, that means it is under equilibrium. So now you can write or rewrite that equation as 225.4 minus NA is equal to F sine 45 degree. So now based on equation 1 and 2, if you are dividing equation 2 by 1, we will get F sine 45 by F cos 45 is equal to 225.4 minus NA divided by 22.05 plus 0.33 NA. That is, both the things we are getting in normal reaction A, and then sine by cos we know the tan, so FF will get cancelled. So tan 45 is equal to 225.4 minus NA by 22.05 plus 0.33 NA. So tan 45, you know that it's 1, and then we can substitute and then we can calculate the value of normal reaction at block A is equal to 152.55 Newton. Once we calculate a normal reaction, then we can substitute the normal reaction value in equation 1 or 2. Then obviously we will find out the value of F, that is 103 Newton. So this force is calculated under the condition of impending motion, that is just to slide. Okay. So hope you understood. Just go through again and calculate, you will understand much better. Okay. So the given problem, you know that the block B rests on block A and is attached by a horizontal rope CD to the wall as shown in figure. So what force F is necessary to cause motion of block A to impend? That one only we have calculated. So that value is nothing but 103 Newton. Okay. So okay, this is the problem for you to solve it and then post the answers in our comment box. So the problem is the coefficient of friction, or that is coefficient of static friction is given, that is 0.40, and the coefficient of dynamic friction is given 0.30 between all surfaces of contact. So determine the smallest force P required to start the 30 kg block moving if cable AB, that is first condition is attached as shown in figure, and second condition is if it is removed. So one is if the cable is attached, what is the smallest force P is required, and if the cable is removed, what is the smallest force is required, you have to determine. So please do it. All the best. Thank you.